afternoon to everyone. So my name is Isobe. I'm the Kawasaki Robotics Engine Company Limited. Today I come from the engine. So anyway, first of all, I'd like to appreciate what I could have joined this forum. And further, I good to the chance and opportunity to make a presentation to the Kawasaki robot and automation systems. And today, given to the table is automotive automation system. So, so around this table, I directly explain today. Okay. And before, I directly explain to our companies the brief companies outline briefly. Okay. Well, please look at this gentleman. This is Mr. Kawasaki. So somebody misunderstanding Kawasaki is some local city in Japan. But our company name is the founder, Mr. Kawasaki. Please understand this. And so Mr. Kawasaki founded in Tokyo in 1878. And last year, we Kawasaki is 120 years anniversary since official registration of the Kawasaki companies. And Kawasaki started shipbuilding. We started just business. Next, now we are Kawasaki heavy industry in the 7 business segment. So, this is ship and offshore to the structure in the first of the business. Now in 7 segment, aerospace, rolling stock, and the ship, and the plant, and the gas turbine, and machine, and the Kawasaki, the motorcycle, is one division. And we robot division, and belong this precision machinery. And we 7 segment in the business, and continue to also doing to the Kawasaki heavy industries. So last year, to the Kawasaki heavy industry, the revenue is 15 billion US dollars. And employee is 35,000 employees all over the world. And so precision machinery to the revenue and total 8.8%. It means to the about 1.2 billion US dollars. But it was a very small volume to the total of the Kawasaki revenue. So now it is our robot business. This one. So 1968, we are combined to the innovation. This one, the innovation in the US company, just developed the new robot. But this one, the hydraulic robot. And we Kawasaki started this 1969, about 50 years later, 50 years ago. And we also developed that this hydraulic and the small robot together with the innovation. And this one, first electric robot, we developed by ourselves. And then to continue to develop to the robot systems. And this one, 1983 to the 90. So we joined to the government to the some project. This one, the deep sea to the manipulator system, we the supply to the Kawasaki. Deep sea to this manipulator systems. And then 88, we are the first, we are the released. So recovery robot system, rehabilitation robot in the past. And this one, in the semiconductor, so production to the robot systems. Now we also the market share about to the 50%. Maybe doesn't know to the we Kawasaki to supply this semiconductor robot because we also the just to the supply applied material added to the semiconductor makers. Installed inside their sort of system cannot find out of the Kawasaki's name this robot. Okay. And then so recently we also developed to the medical and so this one to the collaboration robot, maybe to the previous to the speaker said like this. And also several industry shares. So maybe you know to the this one, automation and automation parts industry using the many robot. Normally to the if to the some to the automation maker so the 200,000 unit per year production. It made to the introduction to the 300 and 500 robot in the one line. It's a very sort of big market for the robot maker. And then this one the same to the painting system. This one this one the automation painting system. This one the iron system, and this one the rail car system with the painting by Kawasaki the robot. And this one, for picture, is supplied to the semiconductor and others of the handling battery of checking. And another is we also supply to the many industry, general industry. So food, logistics, assembly, machine, so the industries. So now I'd like to explain to the Kawasaki Robotics the Tianjin in China market with support like this formation. This is KLCT between the Kawasaki Robotics Tianjin, and this is headquarters. And so branch is Shanghai and Guangzhou and Kunshan. And this one the sales and service to the companies. This is KBN means the robot factory Suzhou. We also manufacturing the robot in this location. And KCRE, this one the Chongqing. We just start another new robot to the production system. Okay. Next is the automotive, so the industry. So we Kawasaki the line concept is like this in saving. Saving means to reduce the total cost. It means the initial cost reduction and the running cost reduction. So this for realize this is the line concept. So reduce the robot cost and reduce the peripheral device cost, improve the production efficiency and the shorten construction time, reduce the installation space. This one just initial. This is running, the flexibility, save water, save energy, and no line stop, and the maintenance cost. So this one is some sort of sample. So you can see this is one stage installed 20 robot. Normally to the one stage 4 robot and the 6 robot. But we Kawasaki suggest some sample stage is a training for the saving to the space. Like this one is some to the customer's line. You know, so this is about installation. Normally to the some to the automotive maker, the main body line, just a 2 line. We Kawasaki suggested 1 line, but the stage number is 20, and the welding point is 2000. This we Kawasaki suggests like this, 1 line and 10 station. And welding point is the same, 2000, between to the half. For this reason, we saw the initial cost reduction to 50%, model change cost 70%, space half, 50%. number station is hard. Some customers are using this line, actually the production. This is just a video. So like this is one stage, maybe 8 or 10 robots installed like this, moving. I cannot say some to the automation makers name. So you can see, oh sorry, you can see this several to the robot type, small one, middle one, and big one, installed like this. These are mainline systems. Next is the parts production systems. Maybe not, this one is 3 robots moving product and using this external positional systems. We Kawasaki suggest 2 robots to the 1 robot to the 1 controller. This robot is 1 robot and 1 controller, and so control to this external positional systems. With success, cost reduction, don't need to interface PLC systems. We just move the robot control like this systems. And we Kawasaki realized like this the same line. We also developed lineup systems. This one our main products in their robot type BX3s. Like this 200 and 300 kg. This robot feature is 3 lightweight, like that. And especially, this robot is internal dress advantage. So normally, when to install some customer outside, so dressing, it means to the cable and the water hose or something. But this robot realize internal robot cable, water hose or something. This one, less cable hose interference in this simulation. Because so almost the automotive maker now is so by simulation system to the in advance to the application study. In this case, if the installed outside cable and the dressing it interfere, this cannot. So in the simulation system, but we Kawasaki robot internal is a harness and the cable. Very easy to the simulation checking like this. And so next to the feature is the no interference because all cable inside. Once so spot welding inside of the car, no interference. Very easy. Just a sample to the movie. Computers. Sorry. Very easy and very so they are simple to the harness cable joystick systems. The same. This will be Kawasaki the line. Other makers line. Very easy. And especially this BX3 robot and developed to the short, so welding to the point in the faster than other competitors to the robot speed. And with B series robot to the line up like this. This one 100 kg to 300 kg. Also the internal cable and the harness. And we can to the shelf type robot we prepare. So customers request. Some customer request to install to the shelf type. Some customers to the prototype, something. And now is the main, so the payload is 200 and 300 kg. Of course, we can supply more than to the heavy duty robot, 330 or 40, 50 or 70, 700 kg. And this one we can prepare as each reach. Maybe we can, I believe we can supply also the automotive makers request robot type, payload and reach something. Next, this one we call NC locator. So install to the carry robot to the one stage. This one, big one robot. This upper. Next, middle. This one, middle size robot. Next, lower, middle, upper, same stage, 3 robots installed like this. And we also there. Three separate working areas: upper level, lower level, middle level, upper level. For the reason, it's easy to install to the many robot one stage. This one there, LC locator. LC locator means 3-axis robot, X, Y, Z robot. So depending on the customer's request, we also they are changing to their reach stroke. This one just video tray. This one is the MC locator. MC locator sometimes use spot weld, so the local level to the car. This one, is the location system. It means to the some customers use many models to the automotive. So it needs fix the location to the car model. Also, I use this one is the location system. Before it is spot welding system. We can use both to the system. And next is like this transfer system. We call MG robot 1.0T, 1.5T. Very, very heavy duty robot. Mainly to the like this transfer to the main body car. So automotive maker, so changing to the line. In that case, lifting or moving this body. But in that case, automotive maker, each model to their new design, new manufacturing, this system, too expensive. For this reason, so customer request to the maker, like this robot, transfer and lifting. Because the way to changing this model, it's very easy to the friction to use this system, robot transfer system. But heavy duty is a weight. Which we need to like this heavy duty robot and some reach. So moving into the floor to the upper side. And this one we developed to the. So honestly speaking, we developed this one robot for the airplane. But we can use this automotive makers because the airplane maker is using just how to say, riveted onto the airplane. Very riveting numbers spotted. And we Kawasaki, they are like that. We also they are manufacturing airplane in our sort of factories. And so airplane to the production engineering, because the robot division, they would reduce riveting system to the by robot. Now is human to the riveting. And sometimes many expensive to the so XYZ robot, too expensive. What's the reason to the our other division request to the robot division to the developers like this also heavy duty robot, because the rebate is very so the pressure level is very high. So what's the reason we need B1 robot? And then we also use next area automatic transfer systems like this. So next, our Kawasaki's own patent. This one, FSJ robot system. Friction spot joint we call like this. It's just a 6-axis robot, and this one, the friction spot joining gun, special gun. It's a 2-axis. This robot is the 6-axis and the 2-axis, 8-axis. This robot system. Controller, one controller, right? This system. Like this. Not resisting the spot wave. This is a friction and the pressure and the joining like this. This one to the resistance spot welding device, like this system. Little bit complicated, but in case if it's very simple, just remote controller on, and this one 2-axis for joining down. Maybe you can find out, compare this cost. Which one is cheaper? And fortunately, we have our Kawasaki's patent. Yeah, another sort of robot cannot use this system. And the automotive maker is so realize lightweight to the body. No wine. So body and the steel. And so resisting spot weld system use steel and steel joint. That this FSG system, of course, with mainly we so they developed first is aluminum to aluminum joint. This is the FSG system. That automotive makers strongly request they would like to use more steel and steel, because aluminum very so they're easy to the joining. That steel and steel is very difficult, because these are two not strong, cannot use so many so they are numbers. Also is we Kawasaki developed these two. And now we are using to the steel and the steel. And further, automotive maker further request now steel and aluminum, different material. And now the aluminum CFRP, more of the light materials. Now is this in this, so there are different material and the CFRP material cannot, resisting spot welding cannot join. What's the reason? They try to use FSJ system, but still, so some trouble. And these tools lifetime. Now we have to develop. Maybe next year we can release this system. And further, so we realize we Kawasaki we Kawasaki controller is very small compared to other so the automaker, almost 1/4, maybe quarter. Very so they are minimized. And our controllers, so they are using to the safety rate. We also developed cubic S system, easy to the space saving, so internal software like this, and easy to the join together with the robot and human. Like this. And of course, the previous the speaker say IoT. Of course, we Kawasaki to the IoT system. We call trend manager system. Yeah, preventive the maintenance by fuel. Anyway, customer request, don't stop the robot. Don't stop to their facility. What's the reason? We are preventive maintenance. We look at actual to their data, robot data. It means to the current, voltage or something. We are looking at, and then to the transfer that's the data, IoT system. Some to the automotive maker already so they install this system using. Okay, this is the automotive system. These are the some of the difference. With Kawasaki, of course, we also supply our robot to the general industry like this. This is a president. Washing machine, air conditioning system, handling. And we saw the Kawasaki suggest this line concept. And we also the partner, it's a system integrator to realize actual to the system instead of the Kawasaki. If we Kawasaki supply this system, maybe too expensive, cannot purchase like this. Okay, these are painting systems. Okay. Anyway, thank you very much. That's my time.